to digital. This is where the magic really starts to happen. Software doesn't inherently know what a start button or a saw is until we explicitly tell it, so we create a cheat sheet to organize our physical reality into digital language. We separate our inputs, the components that feel the world, like the start button and sensor, from our outputs, which act upon the world. For instance, our saw is an output, and in TIA Portal, we map that physical motor to the digital address Q0.0. The fan gets its own distinct output. By building this tag table first, we're essentially writing a dictionary that our PLC can actually understand.
Now, to make this logic work, let's quickly break down the jargon. We're going to use a normally open contact for our start button. In plan terms, think of this like a drawbridge that's currently raised up. It only allows digital current to flow when the button is actively pushed, which lowers the bridge. It's the absolute best way to ensure an action only happens when an operator intentionally commands it.
On the flip side, a normally closed contact works in the exact opposite way. And spoiler alert, it's going to be vital for our setup later on. Think of this as a drawbridge that is naturally lowered, just letting traffic right through. It actually stops the current when it gets triggered. We're going to use this specific logic for our sensor to trigger an action specifically when the wood is taken away rather than when it's placed. And, to manage our timing, we'll be relying heavily on TP timers or pulse timers. A machine doesn't naturally know what 10 seconds feels like, right? It doesn't have an internal stopwatch, so a TP timer dictates that rhythm. Once it gets a signal, it holds an output on for a highly specific preset duration, even if the initial trigger disappears.